Hello everyone, and welcome to the 49th C programming tutorial. In this tutorial, I'm going to be covering the connection between arrays and pointers in C. And hopefully by the time you're done this tutorial, you'll understand that really they're the same thing. Arrays and pointers are equal to each other. So if you get anything out of this tutorial, just array equals pointer. I know I never really made this connection at all in the earlier tutorials, probably because I didn't understand it well enough back then to really even make the connection myself. But as I learn more of this great stuff, I'd hopefully like to clarify that for everyone else that tries to learn this now. So with that said, what we have here is a very simple sort of start function. We've declared a few variables, and we have this array of stuff, and we've initialized it with 1, 2, 3, 4, and 5. And what this looks like in memory, just to kind of show it off, this is a little diagram that I made, and this is sort of the layout. It's really not exactly what it's going to be laid out as, but it is an example layout of addresses that would be made in C. So when I declare these variables and I have to use them later on, they'll get put into memory, and they will look like this. So what's going to happen is, the value for A will get its value put in memory at this address. Then B has a different address. It's offset by 4 bytes, you'll notice. And why is it offset by 4 bytes? Well, it's an int, right? An int has 4 bytes. It is 4 bytes large to contain the value. So the address offset is going to be 4. Then C, the int C, is going to be, again, offset by 4, and it has a value declared to be 4. All right, so then the array is very similar. It's just we've declared that we're going to have space for 5 values. So even if I didn't initialize this, we'd basically have this space set up for the array. And then once I initialize all the different values on the array, then we'd have 1, 2, 3, 4, or 5, or whatever I put in to those values. All right, so this is sort of a basic layout of how memory works in C. Now, to sort of chop that up a little bit, though, there's also the finer details of the address. So in each address, right, we have bytes 0, 1, 2, 3, and just to simplify how this works, right? Each int has 4 bytes. So if we were working with characters, for example, like a character string, we'd have a character in byte 0 and a character in byte 1, and et cetera, right? This is essentially how the memory might be laid out, and we would print out our string. So that's great. That's really what we expect to happen, and this is how it works in C. So C is great because you can pretty much see how everything works. All right, so what we're going to do in our little sample here is we're going to print all these values out. So we're going to print out the address of A, and then we're going to print out the value of A. So that's what I'm doing here. I'm getting the address of A, where it's located in memory, and then I'm printing that out with %p, and then %d is going to just print out the value that's associated with that int. I'm just copying and pasting some code here. This is the exact same thing that I had before, so I'm just going to I'm just printing out the values for everything else. An interesting part, though, comes when we go to print out the array. And this is where I'd like to really clarify for this tutorial some things. So the array, you'll notice I'm just saying array and then %p. And you might be wondering, all right, why didn't he use the ampersand sign to get the address of the array? The reason is array is already a pointer. What we declared here is pointing to the first location of where this array begins. So array itself is actually a pointer to the first spot in that memory. What we're doing when we use the brackets like this, or maybe use this example to start, what we're using in this brackets is we're saying go to, we're going to have this pointer array, and now we want to go to this value, offset it by this amount. So the I, right, if I say I of 0, for example, I'm saying don't offset it by anything. We're just going to go to the value at this pointer. So go to the object at array index 0. If I offset it by 1, what we're saying is, all right, we have an int array, right? The array is an int, and we're going to offset that pointer by 4 bytes, really. So we're going to, for example, if array is pointing to this spot and I say index 1, I'm really saying move the pointer of array 4 bytes, and now I'm going to print out what's at that location. So that's really what we're doing when we're saying the index at that spot. All right, so enough talking about that. Let's go ahead and print this out and see what we get. So you'll notice the ints are fairly standard. We get this long memory address, and this is just where our program is put in memory. So nothing too special, but you'll notice the special part is really the offsets that are created from this. So you'll notice that each offset is actually offset by 4. And don't let the hex fool you. The hex, every value in hex basically can range from 0 to F. The number system goes from 0 to 9, and then A to F. That's just 0 through 15 if you want to think of it that way. The letters are just representative of 10 through 15. And so we're just really offsetting these ints by 4, and that's what we expect, right? Because the int needs 4 bytes. The array works in a very similar fashion. We have an array, and we start at this memory location. That's this array printout right here. You'll notice that's very interesting to note is that the array, when we get the address at the first spot in the array, right? So this code that I've highlighted here is actually representing go to this object that array points to, and in the first case we're at 0, so it's where the array points. Then we're getting the address of that spot. So again, it's going to be the exact same as the printout for array. Then what we're doing is we're offsetting the array, right, by 4 each time because we have an int array. The int means that we have to move by 4 each time. So that's how the index knows how far it's moving. All right, so that's a very simple example of that, and I'm sure that makes enough sense. If we were to do this with characters, this would be a little bit different. So let's throw in some characters here, and I'm just going to make some space. So I'll come back to that in just a bit. I'm going to throw in a bunch of print statements for the characters as well. And this is nothing really special, but I'll just cover what we got. So the first declaration here is for a character of, I'm just calling C_A, and I'm setting it to be A, which is some value in ASCII. Then I'm doing the same thing for B. Then you'll notice I have a char star, so it's a pointer, or it's a string. Also, you'll notice that in the string I have arrays are pointers. Again, the whole point of this tutorial is kind of to emphasize that. So what this really means is that this string declaration is the same thing as really saying string with a size of 22, and I will set it to be this string. All right, so that's really what we're dealing with here, and you'll see that in just a bit. All right, so then in the printout section, I'm just doing the exact same thing that I did above. I'm printing out the values of the characters and printing out the string. The really interesting thing to note, though, is that the syntax that I'm using to print out the characters is the exact same thing that I'm using for the syntax in the array. Again, arrays are pointers. So what I'm doing, string, obviously, we've declared this to be a pointer, right? We have char star, so it's a pointer to characters. And then we're going to say, all right, we have this character offset, and we're going to offset it by, characters 1 byte. So whatever this number is, that's essentially going to be the offset. So that's that. Then we're doing the exact same thing. Again, this and this code are the same. We're going to pointer string, or str in this case, go to the object at index I, then get the address at that location. And then we're just printing that out. So let's go ahead and run that and see what we get. So a few things to note, and I must have goofed on my code here or something. What did I do on that? 73. Not sure what I'm printing out. I must be printing out one too many things. Let me just recount my array here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Yeah, so I had one too many things. This is actually length 21. All right, and I want to go to 21. All right, let me just run that again. All right, so what we have here is you'll notice the characters are being printed out, And the really neat thing to notice though is that the address offset of these characters are offset by 1. And of course, a character is only 1 byte large. An int is 4. So that makes sense, right? Our offset is going to be representative of really how much space we need to use. The string is even more interesting. So the string is going to be, and actually let me throw another print that I'm missing here. I'm just going to actually copy this guy. And this will just emphasize the fact that the pointer is pointing to the beginning of this spot in memory. So let me go back to that string there. We have 32, or F32 is this location in memory. You'll notice that the location is actually quite a bit different, and this is just how C works with strings. When you actually declare a string, strings are actually put in a separate text spot for memory, so this is why the address is different than the other ones. The other ones are put on the stack, but I'll talk about that in probably another tutorial. Alright, anyway, with this, you'll notice that we print out where the string starts, right? That is this print call to str. Again, the pointers always point to the beginning spot of the where the string starts. Alright, and then we're just going through and starting to print out the values. Again, we start at F32, and your increment is by 1 each time, and then, we find the null character. And the null character is how the string knows where it's done. Okay, so that is what we have for the string, and that's great. So that's what we kind of expected. And just to go back to that diagram, maybe to emphasize a little more, each one of these addresses are broken up into 4 different bytes. That is why the characters are offset as they are. But the interesting to note, right, is that again, the string pointer is working the same way as the array. And what I'm going to do right now is just get rid of all this excess code that we have talking about all these other things, and I'm just going to focus on the string itself and the array. Alright, so let me just swap these spots. Delete. Alright. There we go. Alright, so again, we have this integer array, and we've declared it with that. Then we have this char star, which again is the pointer. The point being, though, is that they're both pointers. String is a pointer, and array is indeed a pointer. How do we know this? Well, we can see it kind of just from these print statements, right? We're taking the array, and the array just prints out the beginning location of where this array starts. All that we're doing when we declare this array to have 5 is we're telling the compiler, hey, we're going to have 5 slots that we need to make for this array. Make those 5 slots. Make enough space in memory so that I can fill these 5 slots. The string knows how much it needs because we made a string, so it knows that it needs to have a length of 21, including the null character, and it will make enough space for that string and fill those slots. So that is how this works. Now, going back to the arrays as pointer thing, we can see from the array that we have this specific pointer array. Then we go into these locations. Now, another way of doing this, which is really interesting, is that we can say something like, so let's declare a pointer outside of this. So we'll say int pointer, and let me make it actually a pointer, and we'll get the address of the beginning of the array. All right. So what I'm actually going to do, instead of actually accessing the array directly, I'm going to use the pointer to figure out what we have at each location. So instead of using this notation here, I'm going to say pointer. And again, the pointer, right, is pointing to that location of the array. It just points to what we have. The array index is just what we have at that spot, and we can just get that by dereferencing the pointer by saying star pointer, right? The star in C goes to that value, so the pointer itself is an address, and the star says go to that address and figure out what value is held at that location. So if I go to print this out, and we'll just look at the array for this section. So you'll notice the array, right? It works the exact same way. We've declared these different spots, and each spot, right, has the address. It's offset by 4, and we're printing out those values 1, 2, 3, 4, and 5, right, which are what we declared in the initial array. So the pointer, right, it is the same thing as the array. And one really interesting thing to note, though, that we're doing right here is something known as pointer arithmetic. And you might be thinking, well, why when we say plus plus, you know that plus plus is plus 1. But in the case of pointer arithmetic, if you're working with a pointer and it has a type of int, for example, the pointer knows what type it has, and it knows that it's an int star. In that case, it knows that when it's adding, it will actually add by 4. It will move the pointer by 4 bytes instead of just 1. So this is a very interesting thing to note. It's, again, pointer arithmetic, where if the pointer knows its type, which they do in this case, it's an int star, and it's going to move by 4 bytes if we just say plus plus. All right. Now let's do the exact same thing with this string. We'll say, we'll say character star. This will be C pointer, and we'll just point to the beginning of the string. All right. So the C is just standing for character pointer. I just needed a different name for it. So let's do the exact same thing here. We have C underscore pointer. We'll plus plus it. In this case, it knows that it's a character star. And being a character, it knows that it's 1 byte large. So when I say plus plus here, it's actually going to just increment the address by 1. So instead of changing the address by 4 like it does for the integer array, it's just going to move the address by 1 because it's a character. All right, so let's change the syntax here. We'll just we'll print out the character pointer, and we'll print out what is located at that character pointer. All right, so if I go to print this out, again, you'll notice that it works the exact same way as it did before. We have F64. It's printing out the values at this location. 65 is representative of capital A and C. And if I even wanted to get the values, I could just use %C instead. So if you want to see that, you can see that we have arrays, our pointers. And again, it works the exact same way, right? We're just taking the pointer and we're printing out the address that it points to. And then we're dereferencing that and we get the value at that location. Again, using pointer arithmetic, the pointer knows it is a character, so it will increment it by 1. And that's that. So hopefully this really solidifies your understanding of pointers and arrays in C. Again, they're one and the same, and I just hope that was totally clear. And so, yeah, the real neat things to notice are, again, pointer arithmetic, where by incrementing the pointer by 1, might be doing something different depending on what you have. So if we have an int in this example, we'll actually increment it by 4, move the address along by 4, because that is the offset that is needed to access different parts of the int. And in the case that we're using a character, it's going to increment it by an address of 1, because we're only using characters, which are 1 byte large. Alright, so that's that for this tutorial. If you have any questions on it, feel free to leave your questions in the comments below. In the next tutorials, we'll be talking about the stack versus the heap, and we'll dive deeper into how malloc and free work, or what those actually are, in case you even forget, or I didn't really cover it before. So we'll really talk about malloc and free and the stack versus the heap. So anyway, that's for next time, and I hope you enjoyed this tutorial. Stick around for many more tutorials to come. See you then.